Graphing a sinusoidal function. Let's talk about how to graph one of these things using what we've learned. So our example function is y equals -2 sine of 3x. Always start by deciding which of your four basic shapes you're going to be drawing. This is a sine function. I also see the negative sign sitting in front of it, so I know this is going to be a reflected sign. That's the valley and the hill. That's what I'm about to draw. Okay, what's the amplitude? The amplitude is the value part of the A. The A is -2. The value portion of it, the absolute value, is 2. How about the period? Well, we have a little formula for that. The period is 2 pi divided by the B number. The B number in this case is 3. That doesn't reduce, and so the period is 2 pi over 3. Now let's write down the x-coordinates of our 5 key points. I know I'm going to draw this. It goes middle, low, middle, high, middle. Let's write down what our x-coordinates will be. I know I'm starting at 0. That's where the first one is. And I know I end at the period. That's where the last one is. Well, how can I get the rest? The third key point here is halfway to the period. So if I simply cut 2 pi over 3 in half, I'll have my answer. Well, half of 2 pi over 3 would be 1 pi over 3. If you want to actually calculate it, you would just take 2 pi over 3 and multiply it by 1/2. The 2's cancel, and you end up with pi over 3. But then the second key point would just be halfway to the third key point. So if I just cut pi over 3 in half again, I'll have that one. Pi over 3 times 1/2 would be pi over 6. Well, that's the one you really want to have, because once you have this one, you now know what you're counting by. You're counting by pi over 6 by 1/6 pi. So it goes 0, 1 pi over 6, 2 pi over 6, which reduces to pi over 3, and then 3 pi over 6. Let's see, 3 pi over 6, that would reduce to pi over 2, followed by 4 pi over 6, which reduces to 2 pi over 3. We've got the x-coordinates of our 5 key points. We have all the information we need now to draw a great picture of this function. We want to draw it for one complete period. So go to the x-axis and draw 4 equally spaced tick marks. We know how to label these markings. We're counting by pi over 6. And then on the y-axis, the amplitude is 2, so I need to be prepared to show that. When I say show all scale clearly, this is exactly what I mean. I can see the x-coordinates marked for all of the key points, and I can see the y scaling as well. Now let's put dots at the 5 key points. I know that this function is the reflected sign picture. It starts at the middle, then it goes to the low. At the next key point, it'll be back at the middle. At the next key point, it'll be up at the high, and finally back to the middle. Put dots at those points, and then all you have to do now is connect the dots with our valley and hill picture. And so I've drawn a graph of this function. You should use this same procedure in drawing your own graphs. Finally, let's state the range of our function. The range is simply a list of all the possible y values. It looks like the lowest y value on this graph is -2. The highest y value on this graph is +2. And every y value in between gets used. So using inequality symbols, we can say all y's between -2 and 2, or written in interval notation, all numbers between -2 and 2. Okay, let's try another one. Now we have the function y equals 3 times cosine pi over 4x. In terms of starting shape, this is a cosine picture. There's no negative in the front, so it's the regular cosine graph, the vase. I know that's the picture I'll be drawing. The amplitude is the value part of the A, which of course is 3. The period, we have a formula for that, 2 pi divided by the b. The b is pi over 4. So I'll have to work that out. Dividing by pi over 4 would be the same as multiplying by its reciprocal, which is 4 over pi. The pi's cancel, and it looks like I just end up here with 8 over 1, which is 8. So my period is 8. Now maybe you're thinking, wait a minute, usually we have a pi in our period. Yes, but in this case, the b value caused the period to come out to be a nice number, just 8. The x coordinates of our 5 key points should be pretty easy. We're starting at 0. We know that the final key point is out there at the period, 8, and the other ones can be determined easily. Half of 8 would be 4. That's going to be the third key point. And then half of 4 would be 2. That's going to be the second key point. And now I know I'm just counting by 2's. It obviously goes 0, 2, 4, 6, 8. I have everything I need now to draw a very accurate graph of this function. Put your tick marks on the x-axis, evenly spaced. Label them appropriately. On the y-axis, I need to go up to 3. And now it's time to show the 5 key points. We start with regular cosine at the high, then the middle, then the low, and then the middle, and then back to the high. Now connect the dots in that vase-looking regular cosine shape. Remember, it's a curve, and it should look like it's going flat here at the end, because if I was to keep going, the graph would head downward as it continues to move on. And then what about the range? It looks like this time we've got y values going from -3 to +3. And so we can write the range in one of these two ways. When you're doing this kind of graphing by hand, you can always easily check your answers on the graphing calculator. Let's put this function in our calculator. We want to put in y equals 3 cosine pi over 4x. And then what window are we going to use? Well, we don't want the z-trig window. We want to count by 2's. We want to make our picture match what we did on the paper. So we should go from 0 to 8 for x's, counting by 2's. And on the y-axis, we went from -3 to 3, counting by 1's. If I then hit graph, I should get the same picture that we just graphed on our paper, and sure enough, I do. So use the calculator to check your work. Thanks for watching.